Standard 9th Science and Technology Part 1st, Chapter number 3, Current Electricity. And now in this chapter we are going to study about the resistance and Ohm's law. Now, what is Ohm's law? German scientist George Simon Ohm found the relationship between the current flowing through the conductor I and the potential difference V across its terminals, and stated that if the physical state of a conductor remains constant, physical state of the conductor means its temperature, its physical state, its length, area of cross section, etc. All other factors of this physical state are constant, then the current flowing through it, that is I, is directly proportional to the potential difference V between its two ends. That means I is directly proportional to V. That means I is equal to, now proportionality sign is removed out and instead constant of proportionality is taken. Therefore, I is equal to kV. Here K is constant of proportionality. Now that means V is equal to I into 1 by K. This 1 by K is nothing but the resistance of the conductor. 1 by K is also called as the resistance of the conductor. Therefore, now V is equal to I into R. As we know that V is equal to I into R, if I is to be calculated, then R, which is present in this side in the numerator, it will go in the denominator to the RHS. Therefore, I is equal to V divided by R. Also, if this R is taken to the left hand side, it will go into the numerator, and I, which is in numerator, when it changes its side, it will go into the denominator. Therefore, R is equal to V by I. The relation between the potential difference and I is found out by this ratio, and this ratio is nothing but the R. Now, SI unit of this resistance is, we will put the SI unit of potential difference, that is volt. SI unit of current is ampere, and SI unit of resistance is ohm, which is indicated by the symbol like this. Okay, now 1 ohm resistance is equal to V, that is potential difference of 1 volt, and I, its unit is placed here, 1 ampere. Therefore, 1 ohm resistance is equal to 1 volt divided by 1 ampere. What is this 1 ohm resistance? This 1 ohm resistance is nothing but the, if 1 volt of potential difference is applied between the two ends of the conductor, and due to that potential difference, if 1 ampere current flows through it, the resistance of the conductor is 1 ohm. Resistance and resistivity of a conductor. Now, what is the resistance? When a potential difference is applied across the two terminals of a conductor, the electrons start to move from lower potential to higher potential. While this motion is going on, the electrons collide with the atoms or ions in between the path, and due to this there is a sort of collision between the particles, and this collision will cause a hindrance to the flow of electrons. That means these particles will, that means this opposes the current. This hindrance is called as resistance. And resistivity is, at a given temperature, the resistance R of a conductor depends on the length L, also on the area of cross section, that is capital A, and the material from which the conductor is made up of. This is resistivity. That means resistivity is specific for that specific material. Here a conductor is shown, which is cylindrical one, and this conductor has a specific length and a area of cross section. Now this area of cross section means if the conductor is cut transversely, then that cut surface will form the area of cross section. If the resistance of a conductor is R, and then R is proportional to length, R is proportional to the length, R increases as the length increases. This is relation number 1. R is inversely proportional to the area of cross section. Okay, R is inversely proportional to the area of cross section. That means if area of cross section is smaller, resistance will be larger. That means this width is smaller, resistance will increase. If this area of cross section, that means width or the breadth of the wire increases, the resistance decreases. Here inverse proportion is there. This is the second relation. Now by combining relation number 1 and relation number 2, we will get resistance is proportional to length divided by area of cross section. Therefore resistance, that is R, is equal to, now by taking the proportionality constant rho, we will get R is equal to rho into length divided by area. Here rho is the constant of proportionality, and this is nothing but the resistivity of the material. Now rho is equal to R into A. This A which is present in the denominator, it will go into the numerator, and L which is present in the numerator in the RHS, it will go in the denominator of the LHS. Therefore rho is equal to R into A divided by L. Now putting the SI units, we will get SI unit of resistivity is equal to SI unit of resistance ohm, SI unit of area meter square divided by SI unit of length, that is meter. Now 1 meter from this meter square and this meter will both be cancelled by each others, and then we will get SI unit of resistivity ohm meter.